Hello. Been a while since I've had any update, but I finally got around to programming basic self-check code, putting it in EEPROM, and I kind of lashed together a simple serial port, which isn't using a max 232 like everybody else likes doing. I just used two basic transistors, an NPN and PNP, for level transitions to get a basic crude functional serial port for communications, and stuff there, and hooked a set of 4 leads to port 1 for basic reality check feedback. And now comes the part where you hook the unit up to the normal serial port pigtail that I got running around here all the time, and hook up power to it and see if the thing will communicate, which I'll do in a second. Look it up. Power. And then turn the power supply on. I'll go over to the real terminal screen so you can see I've got it set up with 300 baud. Communication's a bit slow, but I don't know it'll work. Now to the RT screen. Alright, here's the real terminal screen. I turn the unit on. As you can see, it prints out hello right at the top. So I know my board at least woke up. And it's printing something to ROM from ROM. Now I'll change it to the little hexadecimal ASCII display and type in one of the commands is small a, which does basic internal core memory dump. 256 bytes internal memory space. Since this is an 8031, it only has 128 bytes of internal memory space, so the entire top portion is just zeros. Bottom portion right now is just random memory, random data come up as you turn the power on. I'll try one of my other commands that I put into my little test firmware, which is write memory bit, which is small w that respawns a for address that I want to program. I just use 030 for the address, and it asks for D, which is data. Put in an ASCII 2, and I'll just repeat that a couple of times. 031, ASCII 2, right, 32, ASCII 2, right, 33, ASCII 2, and then when I do a small a for internal memory dump, you will see string of 2s in memory. That is the ones that just program just wrote to internal memory. And now for the external memory that I have hooked up to see if it functions, command I have for that is big W, which asks for address, and I'm going to use the send command to send FF which it needs 2 bytes for the address, and then 00 for the data, which it responds R for ready. And then I've completed the command. Now I go to big R to read, and I ask the address. I send it FF again, and you see 0 in the memory space. Big W, right? FF, and I send it FF for the data. Implies it's ready. And read that same memory space. FF. So it's reading and writing to external memory perfectly fine, and I already checked the rest of it. And next program subroutine I've got is big A, which is read all external memory, which external memory is just hasn't been programmed yet, so it's just a whole bunch of random data coming down the pike and stuff. I'm gonna hit the reset button because I don't want to wait for it to do that. A full external memory dump. Alright, when I hit reset, it sent the HELLO for hello and a ready prompt, and do a full internal memory dump again. I'll do is take, and the other subroutine I got is a big L, which loads the external memory with 0. And I'll, L, and now the external memory should be loaded with 0. I'll do external memory dump again, and you see it's all coming up 0, which means the external memory is properly programmed. With the clearing routine, I'll reset the unit again. Alright, the hello prompt. And next routine I got, because if we dump internal memory, you'll see that you only get data from lower 128 bytes. You don't get anything from the upper 128, which is where the special function registers is. And the reason why that is the special function registers can only be read with a direct move or direct read, while indirect read that I used for this routine just come up with 0. If it was 8032, then you'd have memory space there, but not 8031. So how do you get the internal memory space? You have to do direct memory calls, and I wrote a subroutine to do direct memory calls to the normal special function registers and put them in the lower portion of the normal internal memory, and that command is big S. And once it gets done printing out here, you'll see the special function registers right at the bottom of the list. And the last little program I have on my dumb self-test program here is writing to port 1, which is what those LEDs are for. And the command for that is just simple ASCII 1, and it replies back D for the data. And I can send back 00 hex, or I can send back, see I typed in 1 again, it asks for data again. FFX, and I'll let you see what the leads do. Alright, I'm going to take and send the 00 hex command. Send 00. You see the lights come on. And now I'll send the FFX command. And the lights go off, and the reason why the inverse of what I send is because I have the lights, LEDs wired up from B plus or 5 volts to the port, so they turn on when the port goes low. The reason I do that is because 8051 and 8048 ports can sink current, but they are weak pull up, so they can't really source any current, so I don't do any much good for turning on leads in the pull up direction. So I normally just wire them to where they pull down. So alright, that pretty much is it for the self-test program. The board's doing fine, and I'm gonna try putting next video. I'm gonna put in a ROM that has Paulmon 2.1 on it and see how that one works with this board. See you there.